Representing proportional relationships. A proportional relationship is a relationship between two quantities where the ratio of one quantity to the other quantity is constant. Alright, so just remember, if it is a proportional relationship on a graph, it has to be a straight line. And it also has to pass through the origin. Remember that the origin is the ordered pair 0, 0. It's where the x and the y-axis intersect. The constant of proportionality. The constant ratio between two quantities. It's k is the constant of proportionality. It's y divided by x. It's also written like this on your formula chart. Okay, and this is just a manipulation of the formula. All right, let's take a look at example 1. On example 1, Megan earns $12 an hour at her part-time job. This is our constant rate of change, $12 an hour. Show the relationship between the amount she earned and the number of hours she worked is a proportional relationship. Then write an equation for the relationship. Okay, so if we look at the number of hours, we can think of this as x, and we can take a look at the amount earned, which is y. And we just find the constant of proportionality, y divided by x. 12 divided by 1 is 12. 24 divided by 2 is 12. 48 divided by 4 is 12. 96 divided by 8 is 12. The constant of proportionality is 12. So if we're going to write a formula in the format of y equals kx, we could say y equals 12x. The constant of proportionality is y equals 12x. This is a multiplicative relationship. There is no additive relationship. So this is a proportional relationship. All right, let's take a look at the next one. 15 bicycles are produced each hour. The K is 15. Show the relationship between the number of bikes produced and the number of hours is a proportional relationship. Then write an equation for the relationship. So if we're talking about hours and bicycles or bikes, for 1 hour, we can produce 15 bikes. For 2 hours, we can produce 30 bikes. For 3 hours, we can reproduce 45 bikes. And for 4 hours, we can produce 60. If we're going to write an equation for this, y equals kx or y equals 15x. This is a proportional relationship. The constant of proportionality is 15. It passes through the origin. It's a straight line. All right, let's take a look at the next one. Representing proportional relationships with graphs. The graph shows the relationship between the weight of an object on the moon and the weight on Earth. Write the equation for this relationship. Okay, we can say the Earth weight represents x, and we can say the moon weight represents the y. So if we do y divided by x, we have 1 over 6. Y divided by x, 2 over 12, which simplifies to 1/6. Y divided by x, 3 over 18, simplifies to 1/6. y divided by x, 5 over 30, which simplifies to 1/6. The k is 1/6. Writing it in the format of y equals kx, y equals 1/6x. Now let's take a look at the graph. We start at the origin, we go up 1 over 6. We go up 1 over 6, up 1 over 6, up 1 over 6, and up 1 over 6. This is a straight line and it passes through the origin. It is a proportional relationship. All right, let's take a look at number 4 and 5. The graph shows the relationship between the amount of time that a backpacker hikes and the distance traveled. What does the point 5, 6 represent? Okay, well 5 represents the hours. So 5 represents 5 hours. And the 6 represents miles. Alright, so 5 hours for 6 miles. What is the equation of the relationship? Alright, so if we're doing an equation, we are saying we're going up 6 to the right 5. So this first ordered pair is 5, 6. The next ordered pair is 10, 12. And the next ordered pair is 15, 18. So if we do k, which is y divided by x, we have 6 over 5, 12 over 10, which simplifies to 6 over 5, 18 over 15, which simplifies to 6 over 5. So the k is 6/5. Write in the equation y equals 6/5 x. This is a straight line and it passes through the origin, so it is a proportional relationship.